Welcome to Chemical View. Today I am discussing about the coordination compound in organic chemistry. In previous lecture I have taught about the high spin complexes and how to calculate their CFSC values. Now in this lecture I am going to discuss about what is coordination compound, in which how the splitting of the octahedral complexes is happen in this way. So first is splitting of octahedral complexes. Whenever octahedral complex is splitting, so there is splitting of the d orbitals, in which 5 orbitals are there. 5 orbitals are there in which 6 ligands are given in the complex, and metal d electron are filled in two ways. Means octahedral, it means the 6 ligands are present in that complex, and the metal d electrons are which is splitting into two ways, that is T2g and Eg set of orbitals. Here have been shown, that is T2g and Eg orbital. So here in T2g case there is dxy, dyz and dxz. These three orbitals are present, and in Eg set of orbitals there is dx square minus y square, dz square are present in Eg set of orbitals. This T2g set of orbitals are present in between the axis of x and y here, or we can say between the lobes, whereas Eg set of orbitals are present along the axis. This is x axis, or it may be x or y or z axis. So z is the imaginary axis, we consider as imaginary axis in this case. So the splitting of octahedral complexes is like this. In this representation, dxz, dxy, dyz, dx square minus y square and dz square, these 5 orbitals, that is T2g plus Eg set of orbitals of the metal is given, in which the splitting of the orbitals happens is like this. Here the T2g orbitals are given in below the barycenter, and Eg set of orbitals is present in above the barycenter. So barycenters, okay. This happens only in case of octahedral cases. If we talking about the tetrahedral case, so the whereas in tetrahedral cases, here the 5 orbitals given of the metals, metal d electrons, where the splitting will be like this, that T2g will be above and Eg will be below. Here the difference in the barycenter, below the barycenter it will be minus 0.6, and above the barycenter it will be 0.4. okay. In this case of tetrahedral, it is opposite of the octahedral splitting. You can see this. So this will be the splitting of tetrahedral. So here we are talking about the octahedral complexes in which the high spin complex में splitting weak field ligand होगा, तो वो splitting इस तरह से करेगा, that Eg set of orbital will be above, in which and T2g is below. There is no change, but in this case here weak field ligand are like chlorine, bromine, iodine. These are weak field ligand. Is high spin splitting. The weak field ligand always forms the high spin splitting, in which first of all the T2g set of orbital will fill, after that with single electron, in which after that the Eg set of orbital will fill singly. And in next case, the low spin complex splitting, in which the low spin is happening in the case of strong field ligand, in which we are using the strong field ligand are like carbonyl, cyanide, etc., which are pi acceptor ligands. So it will strongly form a bonding with the electrons. So here in this case, the d electron, in which First of all, here in case of high spin there will be singly filled T2G orbitals firstly. In the second case लो स्पिन में ऐसा नहीं होता है. लो स्पिन में ये जो स्ट्रॉन्ग फील्ड लिगेंड्स जो होते हैं दैट इज बाय एक्सेप्टर विच विल बी first of all it will fill in the T2G set of orbital, and after that it will fill the EG set of orbitals. So this was discussion about the tetrahedral and octahedral splitting of the d metal orbitals with ligands. Now we will see the example of low spin complexes in which here the ligands we are here the ligand is not strong ligand. This is we can say the weak ligand, weak field ligand, in which we know the ammonia is neutral in nature, so that if we calculate the oxidation state of the cobalt, here we consider as X, in which ligand ammonia is neutral, so you consider as 0. After that +2 is the oxidation state overall. So after that the oxidation state will be +2, and cobalt is D9 complex, in which we have to subtract the oxidation state of the complex, so that it will be D7. and this D7 high spin complex है, तो हाई स्पिन कॉम्प्लेक्स है तो वो क्या करेगा, पहले T2G को कम्प्लीटली फिल करेगा. आफ्टर दैट द इलेक्ट्रॉन विल गो एक्साइटेशन इन द केस ऑफ EG ऑर्बिटल्स. So we can calculate the CFSC values of this complex like this. This difference is the minus 0.4. Here is the difference is 0.6, so that minus 0.4 into T2G set of orbital plus 0.6 into EG set of orbital plus into mean pairing energy. In this case, why mean pairing energy is given, because here we this in this D7 complex, here is the two pair electrons are there, and in this T2G set of orbitals, here the three paired electron are given in the T2G set of orbital. Here we have to subtract in this 2 to 3 minus करने के बाद वन पेयरिंग एनर्जी आएगा. सो इससे मल्टीप्लाई करना पड़ेगा. उसके बाद that will be calculation, that is after calculating of this it will be minus 1.8 del 0 into this is the subtraction, that is one mean pairing energy is given, so that the CFSC of a low spin complex in case of cobalt hexacyano2 plus ion is found to be minus 1.8 del 0. I have already given the example of high spin complex in my previous video. You can check out. Thank you.